Cosets are subgroups. Subsets. So I like to say subgroup because subgroups are subsets of a group. Cosets are subsets of a group that partition the group. Partition the group, dividing it into even sections. Dividing it into even sections. What's the problem? Okay. So we are saying that cosets are subsets of any given group that partition the group into what? Even sections. We know partition. When you divide anything into bits, we'll call it a partition. So let's write. Cosets can be either left or right. That is, we have left cosets denoting the addition on the left, while right cosets is signified right cosets are added on the right. A group of cosets. Is called the quotient group. It's called a quotient group. A group of cosets is called a quotient. Yeah, settle down. Are you room your book? Put your bag away. So we are saying that we have two kinds of cosets. The first is the left coset, and the second is the right coset. It is left because we are doing the addition from the left. It is right because we are doing what? The addition from the right. So let's quickly look at a few. Let's find all the cosets of the subgroup of the group Z12. So you write the question and put your pens down, and then we look at how we find all the cosets of this in this question. Find all the cosets of the subgroup 048 of the group Z12. Z12. Hurry up, put your pen down. Which one's right? First. You all ready? Okay. Hurry up. Okay. So let's see. What is Z12? Who can list the elements of Z12 for us?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Is that all?
That's all.
Is that all?
Yes.
Okay, thank you. So this is the group Z12. This is the group Z12. Now let's see how to find the coset of this group using the subgroup 0, 4, 8. So we are going to add each of these elements to this group. That's the meaning of coset. Now, if we are going to use the left coset, we are going to add from the left hand side this way, plus our set 0, 4, 8. If you are doing it if you send this on the right hand side, that means right coset. Do you see the difference? So the addition, the set is this way. So this number determines. So we are adding all the elements of the group to the subgroup. When you are doing it from the left hand side, it's called the left coset. If you are doing it from the right, it's called what? The right coset. So 0 plus this. So let's see. If you add 0 to this, what do we get? Isn't that the same thing? The same thing. Let's add 1 to 8. Are you watching? Let's add 1 to it. But remember, we are doing modulo 12. 1 plus 0, 1 plus 4, 1 plus 8, 9. Let's add 2. 0, 4, 8. 2 plus 0, 2 plus 4, 2 plus 8, 10. Let's go on. 3 plus our subgroup. What do you get? 11. Okay. Next one, 4. Okay, sorry. 0, 4, 8. What do you get?
8, 0,
4, 8,
0.
0. It's a group. It's the same as what? 0 plus the subgroup. Can you see? Is it not the same thing?
Yes.
Alright. After that, we'll write them out. Don't worry. So let's see. Some of them will be the same. It's in from now going. All of them will produce something we have done already. But let's do all. 5 plus 0. It's what? 5. 9. 5 plus 8. 30. 30 modulo 12. 1, eh?
Yes.
Can you see? 6 plus this. What do you get? 6, 10, 2, 40 modulo 12, 2. Is it not somewhere? It's somewhere. Can you see? 7 plus 0, 4, 8. Yeah, slanting, you won't get it clear. Stand straight, please. If not, the video will not be clear. Stand straight. You don't block them for long. Once I finish writing everything. So 7 plus 0,
7,
7. 7 plus 4,
11,
11. Plus 8,
20,
15. 15 modulo 12.
28,
Eh?
3.
3. Is it also somewhere? Yes. After that, we'll write them out. Those that are the same. What's the next one? 8. 0, 4, 8. What do you get?
8.
8.
0.
8 plus 4, 12. 12 modulo 12,
0.
0. 8 plus 8, 16.
16.
16 modulo 12,
4.
4. 9.
9.
What do you get? 9. 1.
5.
3. Are you sure?
Says 5.
Wait. 9 plus 0, 9. 9 plus 4, 13. 13 modulo 12, 1. 9 plus 8,
17.
17. Is it 17?
Yes. It's 5.
17. 17 modulo 12. 17 minus 12,
5.
5. And 10. 10 plus 0 modulo 12.
Say
10, eh?
10.
Thank you. 4 plus 4, 10 plus 4, 14 minus 12, 2. 10 plus 8,
18.
18 modulo 12,
6.
6. Very good. 11. 11 plus 0, 11 plus 4, 15. 15 modulo 12, 3. 11 plus 8, 19. 19 modulo 12, 7. So let's see, let's write out those that are similar, that are the same. This one, this one is equal to this one.
Yeah, and then the 4.
Are you see?
4
Yes,
plus.
4 plus.
4 plus.
And the other side.
Yeah, 4 plus.
This one is the same as which one? Where?
4.
Yes.
And then 8. 8.
Yes, and 8 plus.
8 plus.
8. 1 plus this is the same as what?
8.
8 plus the subgroup.
8. Yeah.
Still on the first one.
And that is.
We are still on the first.
The first one.
The first one.
0, 4, 8.
048.
Yes.
Yes.
There's another 048.
That's
Is 804.
Huh?
8.
804. That was it here.
Yes.
We have done it.
So
Wait,
0, 4,
but then this one is not here.
Yes, 5. 5 plus the subset.
Let's write them out first.
Okay.
Let's not mark them. Let's write them out. So we are trying to write out those that are the same. You just know you don't need to work. You just stay there. So 0,
4, 8.
0 plus our subgroup. Let's represent our subgroup by 8. It's equal to what? And then which other one is equal to this one? Which one is equal to this?
4 plus.
0 plus 8 is equal to what? 4 plus.
4 plus.
That's all then.
8 plus 2.
There's another one.
Yes.
8 plus 8. That's all for this one.
Yes.
What of this? Is this
159.
159?
Is 5 plus.
1 plus 8. You added 1 plus, you had 159. Isn't it another 159 somewhere?
5 plus 8.
5. 5 plus what? 8. Is there another 159? 9. 9 plus 8. Is that all?
Yes.
Yes. Is there 2? Is this one similar to another one?
Yes.
So 2 plus 8 is 6 plus 8. 2h. 2h is the same as what?
6H.
6 plus 8. Is that all?
10 plus 8.
10 plus 8.
That's all.
That's all. Is there any other similar ones? 3.
7. 3 plus is
3, 7, 11. Is there?
yes. It's
3
7
plus 8 is the same as what?
7 plus 8.
7 plus 8.
11 plus 8.
11
Plus
plus 8. Is that all?
Yes. Yes.
That's all.
That's all.
That's all.
Yes.
Okay. So let's write out the cosets and see whether they will form a group. Are you watching? Cosets are subsets that partition it into even sections. So let's see all the cosets we have gotten. Let's write them out and see whether when we put all of them together we will form the group. Are you all here? So that you understand what we are doing. So let's write out all the cosets. We have 0, 4, 8. Is that not it? We have 1, 5, 9. We have 2, 6, 10. Don't let them overlap.
7, 11.
We have what? 3, 7, 11. Is that all?
Yes.
Watch. Are you watching? Is that all? All we have gotten. Can you see? Do you see another thing that is there that is not here? We are writing out all the cosets. Watch. Is there any other one we have found that is not in this 4? Are you all there? So these are the cosets we have found. Now let's write them together. Are you watching? Now let's write them together. You have to be putting the camera down. If you raise it too much, it won't be clear. When I'm down, put the camera down, phone down.
It's clear.
Bring it down.
It's clear.
Sometimes you have to do like this. So, if not, you'll be sending the thing out, please. Bring the phone down, it's down, and be watching. So, let's write the sets together, the cosets together, to form the group. Can you all see? So, 0,
1.
0 is here, 1 is, let's mark them out. The next one, 1. Are you watching? 2. 2 is here. 3. 3 is here. 4. Where is 4? 4 is here. 5. 5 is here. Are you watching? Is that 6? 6. 6 is here. Is that 7? 7. 7 is here. Is that 8? Somewhere. 8. 8 is here. Is that 9?
Yes.
9. 9 is here. Is that 10? 10 is here. Is there 11? 11 is here. Have we finished marking all the coset elements? Yes. So let's close and now compare this with our main set. Are they the same?
Yes.
Yes. Do you understand the meaning of partition? Partition is when you put them together, you must form the same thing. You understand what the meaning of coset are? You have just partition, you have divided it into different sections. At the end of the day, when you put them together, you must form the bigger set. That's all. If they don't form this, then you have not finished. Then your cosets are wrong. Any questions? What's the problem? Any confusion? Tell me. What's the confusion?
With the operation, like we use plus. It's like we use the addition operation. But in the question, it didn't state as which operation to use. But we decided to use addition operation. Like is it in all cases use addition, or we just choose it, or there will be a case that you mentioned a different.
The method used, we could have added here under addition, so that we are doing modulo under addition. Any question? Any question? Cosets are additive, so we are adding this to every element of the subgroup that is given or the subset that is given. You are adding, you are not multiplying. You are adding. So, I will travel with you. Single. So where? Find all the cosets. Cosets, so is it double S or one S? I'm using it's 2 S. We're using 2 S one. Okay. Find all the cosets of 4Z. We are using 4Z as our subgroup of Z. So let's write out Z. What is Z? Set of integers. Negatives and what? 0 and positive. So negative 1, 0. Let's do a number of them so that you will see. Let's do negative 3, negative 2, negative 1, 0, 1, 2, 3. Easy. Can you all see? So this is our set of integers. Stop writing, please. Stop writing. How will 4z be? Who can give us a group? 4z, a subgroup. 4z. This is z. So do it for me. 4z. 4 times z. So multiply for me. 4 times this is what? It's what?
Negative 12.
Negative
12.
4 times this. Negative 4. Is it 2?
Yes, sir.
Is it 2 here?
Yes, negative 4.
Is it 4?
Negative 4.
Negative 4. It's negative 4. Then here 0. Here. 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 12. Can you all see? Cosets. Who can tell that? This is our subgroup. Is that not it? This is a question. This one is the subgroup of it. So how do you find the cosets? What did we do the first example? Who can tell us?
Added individual elements of the subgroup individually to each element of the main group to get our coset. So,
We are taking each element from the integers, the main set of integers, and we add it to the 4 set. So when I add it to the 4 set, then we are going to obtain all the cosets. So in order.
So do it for us. So what do we do? In this case, what do we do?
So in this case, when we find all the cosets of these.
Tell us that one. What are we going to do? Tell me, what should I write?
So now we are going to write negative 3. Negative 3 plus the 4 z. So which is negative 12, 8, negative 8, negative 4, 0, 4, 8, and 12.
What are you telling us? We should do what? I should write what?
Negative 3. Negative 3.
Plus 4z.
Do you necessarily need to start from negative 3? Do you necessarily need to start from negative 3?
No, you can start from.
From. You necessarily need to start from negative 3 to be able to obtain the values. You can tell us. Somebody said we should do negative 3 plus 4z. Then what will be the next one? What will be the next?
Negative plus 4z.
Negative 2.
Plus 4z.
And
Negative 1 plus 4z.
negative 2 plus 4z.
And negative 1 plus 4z.
Negative 1
Plus 4z.
plus what?
4z.
4z.
And then 0 plus 4z.
0
plus 4z.
So you see, you are coming to 0 plus what?
Plus 4z.
4z. So who can tell us? Instead of starting from the negatives, where can we start? Where can we start? To mean the same thing.
You can start from the 0.
Very good. Are you watching? Don't be confused. So watch. So we have 0 plus 4z. 0 plus 4z. What do we get? Who can tell us?
Negative 12.
Negative. Is it 12? Okay. Very good. It's 0, so it's the same thing. Very good. So let's just write 4z. Is that not it? Yes. It's equal to 4z. Thank you. Then 1 plus 4z. will give us what?
Negative 11.
Mm-hmm.
Negative 7.
Negative.
11.
Uh-huh.
Negative 7.
Uh-huh.
Negative 3.
Uh-huh.
1.
1.
5.
Uh-huh.
9.
9.
And then 12.
Is it 12?
13.
13. Thank you.
And point 1.
Uh-huh. 2 plus 4z. What do you get?
Negative 10.
Negative.
10.
Is it negative 10?
Yes.
Uh-huh.
Negative 6.
Uh-huh.
Negative 2.
Uh-huh.
And 2.
Is it 2?
Yes. 2 plus 0.
2 plus 1. Oh?
Plus 0.
How well is it? Sorry, I'm watching here. Rather. Thank you. Here. 2 plus 0. 2. 2 plus 4.
6.
2 plus 8.
10.
2 plus 12.
14.
14. Thank you. Let's see where it will start to repeat. So be watching very well. 3 plus 4z.
Negative 9.
Negative.
9.
Be very careful. Don't give a wrong answer. So let's all work it together.
It's
And
negative
3 plus negative 12. Negative 9.
Negative 9.
Okay.
Negative 5.
Uh-huh.
Minus 1.
Uh-huh.
3.
Uh-huh.
7.
Uh-huh.
11.
Uh-huh.
15.
15.
If you are wrong somewhere, we will not get the answer. So take your time. Uh-huh. 4.
Negative 8.
Negative 8.
Negative 4.
Mm-hmm. Let's say 4. 4 plus. Where is it? Here. 4 plus. 4 plus negative 8. Negative 4. I want to verify that one. And here.
0.
Uh-huh.
4.
4.
8.
8.
12.
12.
And 16.
16. Uh-huh.
This will be negative 7.
5.
Negative
5.
Negative 7.
3.
Negative.
7.
Uh-huh.
Negative 3.
Negative.
Yeah.
So this is 15.
Negative 3.
1.
Uh-huh.
5.
Uh-huh. Yeah, don't give me answers. Me, I'm not working on.
4.
Now well,
I should do it. If you are not watching where we are adding, you can add here, you give a wrong answer.
So let's start again.
So be careful, please. Let's start this. We are adding to the same group, so take your time, please. No. Uh-huh. 5 plus negative 12. Negative 7. Uh-huh.
minus 3.
Negative 3.
1.
1.
5.
5.
9.
9.
13.
13.
17.
17.
Yes.
Okay. 6 plus 4 z. Negative.
6.
Uh-huh.
Negative 2.
Negative 2. Uh-huh.
We have 2.
We have 2.
2. Uh-huh.
6.
6.
10. 10.
10.
14.
14.
18.
18.
18.
18. Uh-huh. 7.
Plus.
So let's see 1.
Like 5.
1.
Like 1.
3.
3.
7.
7.
11.
Eh?
11.
Uh-huh.
15.
Uh-huh.
19.
Mm-hmm. Uh-huh.
No, there's now a pattern.
8. Uh-huh. 4.
Z.
Is it?
Yeah.
What do we get?
Negative 4.
Negative.
4.
Uh-huh.
So let's see which one.
Negative 4.
0.
0, eh?
4.
Uh-huh.
8.
8.
12.
12.
16.
16.
20.
Eh?
20.
20.
Yeah.
Okay. Who can tell us? What have you observed?
It's not repeated. It's not repeated.
So what have you observed?
So, the negative side, that's the left side.
Uh-huh. What are we seeing?
It's diminishing or it's increasing.
What are we from there?
The positive integers are increasing.
The positive integers,
They are increasing.
they are increasing.
Yes, whilst the negative integers are diminishing. So if we move on to like 9, 10, 11, and 12, it will completely vanish the negative side, leaving only positive side.
The what?
The negative aspect is diminishing, and then the positive part is what increases. So when we continue, the positive part will get bigger and bigger.
Mm-hmm.
So in that case, we will repeat itself.
Negative 7.
Or negative 4, negative 7, negative 3, 0,
Negative 3.
negative 3, 4,
1.
negative 3, 8,
5.
negative 3, 12,
9.
9.
So it's like,
Is that what you're talking about?
no, saying that
If we add,
in the generation of the 4Z, that was where we started from 0. So
wait.
we needed to have generated from -3, not
No, this is 4Z, so tell us. You're talking of this set.
yes, yes.
So this 4Z.
We should generate it from -3
For negative,
3 going.
wait. 4Z, you have to multiply 4 by Z. This is Z. 4Z means 4 times Z. So here cannot be negative 3.
Yes,
Or?
where we did 4Z.
4Z means 4 times
We
Z.
started from 0 here.
We started from negative 3. Yeah. Yeah.
Yes. So we should start from negative.
Here we started from 0.
Yeah. We should start from -3.
So that's the one we are doing here. You are saying no again.
So if we finish, we realize we will get it.
But that's what we have done. Are we getting it? Or what are you saying?
Yes.
Continuously.
Because
So let's continue. Let's do negative 2.
Continuously.
So don't stop us. Is that what you want us to do?
Yes.
So let's do and then you explain what you are saying. So we have done negative 3. So you want us to do negative 2 before 0. So all the things before 0. Is that not what you want us to do? So that's how we want to do what you are saying. So 4Z. So negative 2, 4Z. What do we get? Negative 14. Let's take time and do what he said. Then what?
negative 10.
Negative 3.
10.
Yes, 10. Negative 10.
Negative 6.
Take your time. We're adding negative 2 to this. So we are filling the third one. We are now here.
Yes.
Negative 2 plus 0.
Negative 2.
Negative 2 plus 4. 2. Negative 2 plus 8.
6.
Negative 2 plus 3.
10.
So let's do negative 1. So negative 1 plus negative 12.
Negative 13.
Negative
13.
negative 9.
Yes. Negative 5.
Negative 5.
Negative 1.
Negative 1.
3.
3.
7.
7.
And 11.
11.
Yes.
So let's see what you are saying. Let's watch it together. Augustine, let's up. So explain with what you are saying. So we start from negative 3. We have started from negative 3. So explain what you want to explain.
So when we look at it, what we are having, if we finish up to the
Where?
yes,
We finish up to where? It has no end though.
okay. So it we're supposed to get it is now a subgroup.
Yeah.
4Z.
4Z.
The coset is supposed to be forming a subgroup. So because it is not having a limit, I'm saying that it's a subgroup of it.
What is a subgroup? Which one is a subgroup?
The one we have formed.
Which one will be formed?
So what I understand from what you say is that because this one is infinite, by all means, you don't know your limit.
Is it?
Like when you combine all of them, because it's not, there's no limit for the integers. So by all means, get the answer. That's
I want somebody to maybe tell me what we are supposed to write. You are getting there. Position yourself well. What do we say? What are our cosets? 4z. 1 plus 4z, is that not it?
Yes.
2 plus what? 4z, 3 plus 4z. Every other thing you do, will get one of them. If you are extending going, continue and see, you'll be arriving at them. Any question? You also Thomas, Albert, okay. Thank you for the other day, and you saved me. When I was going to So our cosets are 4z, 1 plus 4. You know 4z is the same as 0 plus 4z, right?
Yes.
So we also have 1 plus 4z, then 2 plus 4z, and 3 plus 4z. Any other subset, you will get one of these 4. Any question? And you're asking me, the boss is here. You only ask your colleague when I'm of this set in Z9 and that's write the question quickly and let's solve it together. Find all the cosets of this subset of Z9 of Z9. So want to find all the cosets of this subset of this bigger set Z9. You can tell that what is Z9? What is the set Z9? 0, 1, 2, 3, 4, 5, 6, 7, 8. That's right. That's right. That's all the elements of this set. That means we find the process of this under this under addition, in this under addition. Process. You know it's left process or right process? Here is your head. We have used left before. So let's just write. So let's assume this one is A. This is a subset. That's a subgroup of this. So let's assume A. So we use right process there. Yes. So the first, so let's see. 0 plus this. What do we get? 0 plus 0.
0.
0 plus 3. 0 plus 6. 6. It's the same as what? 8. Now you see. 8. This one. Add 0 to it, you get the same thing. Yeah? Now, 8 plus 1. I watch it. 8 plus 1. Where is 8? So 1 plus 0, 1. 1 plus 3, 1 plus 6, 7. Don't forget our modulo is what? 9. So when we reach there, take note. So H plus 1 will get this. Then H plus 2. H plus 2. 2 plus 0. Are you watching? 2 plus 3. 5. 2 plus 6. 8. And let's go 8 plus 3. So let's watch and see where it is going to start repeating. 8 plus 3. 3 plus 0. Are you watching? 3 plus 0. 3. 3 plus 3. 3 plus 6. 3 plus 6. 9. 9 modulo 9. 0. What is this saying? Is that the same as 8 plus 0? Can you see? 8 plus 0. 8. This is the same as 8. 8 plus 0. If we continue, if you want, let's continue. We have done 3. So let's continue and see what happens. 8 plus 4. Let's see how it is rotated until you repeat it. 8 plus 4. So 4 plus 0. 4 plus 3. 4 plus 6. 10 modulo 9. 1. Did you get this before? Can you see?
Yes.
147. 147. You see? Have you seen the repetition has started? So let's see. If immediately instead of repeating, you can stop and then check the coset and see whether they will form the whole given main group. Are you all here? So let's see. If we assume that the cosets are h plus 0, h plus 1, h plus 2, because I started repeating from here. Can you see? Are you watching? Are you confused? So h plus 3, it starts to repeat. So let's see if we assume our coset. If we stop there and see our coset. Sorry. Our h plus 0, h plus 1, h plus 2. So let's see. Let's write there. H. So let's write our, and see whether they can form Z9. Are you all watching? Let's add this to this today. Let's put them together. The union, let's unionize them. Let's put them together and see whether they will form this set. Are you all there? This group. Okay. Can you see? If they don't, that means we don't have to stop. We have to continue. Can you see?
Yes, sir.
So Z9. So let's listen. So 0 is here. Can you see? Yes. 0 is 0. 1. Why is there 1? 1 is there. 1. 2. There's 2.
3.
2. There is 3.
4.
3. 4. There's 4. 4. And then
5.
Is that 5? Yes. There is 5. Good. Is that 6? Good. There is 6. Is that 7?
Yes.
7 is here. Can you see? So we write 7 there. Is that 8?
Yes.
There is 8. Is there any other thing again? No. Does it for? Can you see? Yes. So take note of that. Anytime it starts to repeat, it's possible you have found all your concept that you stop. But you have to cross-check whether you have really met all the partitions that form it. Lagrange Theorem, Lagrange. There was this man called Joseph Louis Lagrange. I think 1736 to 1813. So he was the one who came out with a theorem regarding what we are doing, cosets. So this was what he said, that if G is a finite group. What is a finite group? Who knows? If G is a finite group and H is a subgroup of G, then the order. Then the order of the subgroup H, comma, written as this is, or let's just say device, instead of saying it's a divisor, let's say devise the order, devise the order of the group G written as this. So when we say the order of the subgroup H, devise the order of the main group G, all what we are trying to say is that the order of G is a multiple of the order of H. Thus, we mean that the order of G is a multiple. It's a multiple of the order of H. Something divides something. It simply means that the bigger one is a multiple of the smaller one. Basic is a multiple of the smaller one, the order. And we know order. Order is what? Number of elements. So we are saying that now the order of G is a multiple of the order of H. The order of H. The order of H. The order of H. You know so that the number of cosets of any subgroup in a group is the order of G over the order of H. So when we divide the order of G by the order of the subgroup, then we know that this is the number of distinct cosets of a given group. You understand? This is the number of cosets we are going to get. So somebody should check the immediate example that we just did. How many cosets did we get? How many cosets did we get? The question we just looked at. How many?
8 cosets.
8 cosets. Yes. Now divide and count how many elements. What is the order of the main group?
16.
16. Are you watching? Are you watching the Lagrange Theorem? Or you are still writing? I should wait. All right. Finish copying, then we explain. Sorry. Before we call the number of, we call the number of cosets. We call the number of cosets the index. The index. The index. Written. Call the number of cosets the index written G. That. So if the index is written this way, and they are saying that the index, the number of cosets is the index. So if this is the index, and what is our number of cosets? This. So it means the index is equal to the order of G over the order of H. Order of G over order of H. video. Let's do an example and prove it. Are you there? Let's show. We'll not use the one we just finished. So let's solve an example. So an example, if we pick Z6, let's pick Z6, and then let's pick our H as 0, 2, 4. So let's pick our H as 0, 2, 4. So let's find our cosets. Then we'll verify from all what we have said. So Z6, someone should give me the elements of Z6. What is the group? Z6, the group is what? 0, 4, Can I continue? Thank you. So this is Z6. So let's start. Should you write coset or left? Left coset, right coset there. Okay, so right coset. H plus 0. So this is H. This is 0. So let's go. We are going. Are you watching? So when we add 0 to H, we still get the same thing. That was it. In modulo 6. So we still get 1, 3, 4, 5. Sorry. 1. 0 plus 8. Yes. 1 plus 0 to 4. Can you see? H plus 0. This is H. Can you all see? So we've gotten this. This is the same as H. So H plus 0 is H. Now let's see. So we have done 1 with 0. So H plus 1. Are you watching?
Yes.
So H plus 1. 1 plus 0. 1 plus 2. 1 plus 4. 5. Don't forget we are doing modulo 6. So let's go on. H plus what? 2. H plus 2. Can you see? We are here. Hey. Is it right? So we are adding H to 2, eh?
Yeah.
So where are we? What do we get? 2 plus 0, 2. 4. 6 is what? 6 modulo 6, 0. Can you all see? Yes. So this is also what? H. Can you see? Let's go on. H. So you're watching. When you see that you have obtained all the values of this, you can stop. Can you see? So watch. 0, 2, 4. 1, 3, 5. Is that not all? You see that it will start repeating. Can you all see? So you don't necessarily need to do the rest. So let's see. What are our cosets? Our cosets are what? H plus 0, right? Then H plus 1. Can you all see? Yes, this one is a coset, this is also a coset. 0 is here, 0 is here. 1 is here, 1 is here. 2 is here, 2 is here. 3 is here, 4 is here, 5 is here. So we are done. Can you see? So these are our distinct cosets. The others will be repeated. Do you understand? So once you get your main group, you stop and then you write out your coset. Now let's see how we apply these things that we have just said under Lagrange Theorem. Are you watching? So we have now found the coset of Z6 under addition using the subgroup 0, 2, 4. So let's see, what did they say first? That if G is a finite group and H is a subgroup of G, then the order of the subgroup H divides the order of what? The group G. So let's count. What is the order of H here? Let's watch, everybody. What is the order of H in our question? How many elements do we have in H? 3. What is J? How many elements do we have in J? 6. Can you see? So they say the order of the subgroup divides the order of the main group. Or it is the same thing as saying the order of the main group is a multiple of the order of the subgroup. It's not the same thing. If this divides it means the other one is a multiple. So that means when I multiply this by something, I must get this. Is it not true? So you multiply 3 by 2, you get this. So we have satisfied the condition for what? Lagrange. Now let's see again. What did they say? The order, okay. Note that the number of cosets of any subgroup, are you watching? The number of what? Cosets of any subgroup in a group is what? The order of G divided by what? The order of H. So let's see. Are you watching? The order of G divided by order of H. We now know this, we know this. So let's count. Order of G over order of H. What's the order of G? 6. What's the order of H? 3. 6 divided by 3? 2. How many cosets did we get? Are you watching? Watch you. How we apply Lagrange Theorem. Oh, you are watching. Thomas. Where you are, Thomas? Sorry. Sorry. Okay. Sorry. The way you are watching. How you are following. So we are just interpreting the Lagrange Theorem and its consequences. So we have interpreted, and now we are saying that the index is the same as what? The number of cosets, which is gotten by the order of J over the order of H. So the index, so in the question I can ask you, instead of telling you, I will not even ask you to find this over that, I'll ask you what is the index. And if you know the index means, do this. Are you all here? I just ask you, find the index. I may not even ask find the coset first, I'll say find the index. Are you all here? You don't need to find the coset before you find the index. Is it not true? Can you see? You don't need to find coset before you find the index. So I can just ask you to find the index. Index means order of this or order of that. Are you all there? And I can ask you to verify all that we have just illustrated. So any question? Any question?
We do that. This one allows you to know the number of cosets.
Yes, to tell you what to expect. To tell you what to expect. So the other example. Yes.
The set is 16, and then the cosets are 8.
So the main group, the group is what? Is 16. The order of the group is 16. And the order of the coset, the number of cosets was what? 8. So you see? So 16 and 8. You see that 16 is a multiple of 8. Do you see? So 8 divides 16. So that means it's satisfied. Can you see? There's no way it will not be satisfied. Anytime they give you a question, all this will be satisfied. No way. So it operates on what? Lagrange Theorem. The Lagrange Theorem must work anytime you are finding cosets.
So, since you said there's no way it will not satisfy it, then when there's a question given, we already assume that it will satisfy. So can we just draw into conclusion?
You draw a conclusion with your reason. Any conclusion you are drawing, you must give a reason. So what is the reason? So you must give, like the way we just made 16 and 8. So you must work before you can know that. You see? So you must work it out and you know that it is this, it is that. So 16 is a multiple of 8, or 8 divides this. You will now put it in your explanation. Any other question? So you see that when you divide 16 by 8, you see you get, when you divide 16 by 8, what did you? Have you seen? So when you divide 16 by the 8, how many? You say 8, so it's 16 by 8. I'm not getting you.
16 by 8 is 2. 16 divided by 8.
So the order of the subgroup. The order of the previous example. The order of the subgroup is 2.
It was 2.
Yes. 16 by 2.
Very good. So the order of the H was 2. Very good. And this one, the order is 16. So 16 divided by 2 is 8. And that's the number of what? Cosets. So you have the number of cosets as well. 8. Very good. Thank you. So you see that it's satisfied. Are there other examples that we did that you think they will not be satisfied? Are there any examples? It's U12. And now H. It's 1, 5. So let's do it together quickly. We are doing U12. So U12. Pen down. And down. And down. So let's do it together, please. Our U12. Let's write down the group U12.
That's 1.
5.
7. 11.
Now, okay, thank you. So we know our U and we know our H as 1, 5. As 1, 5. So let's see whether it will work here first. The order of this, what order of this is what? The order of this. What the order of this? This is what? 4 divided by 2. What do we get? So what's the meaning of the 2? That will be what? The number of cosets we are going to get. Are you watching? So you can just do and then you start. So let's see how we get our cosets. So this is our J, this is our U. So let's start. If you add 1, so this now let's do left coset there. 1 plus H. Left coset. 1 dot H, sorry. 1 H. What do you get? 1, 5. Okay. What is H? 5 eh? 5 H. We are here. 5 H, what do you get? 5 times, hey. We are here. 5 times 1 is 5. Can you see?
Yes.
5 times 5, 25, modulo 12, 1. Can you see? Can you see?
Yes, sir.
So let's continue. This one is also what? H. So 7, we are here. 7H. 7 times 1, 7 modulo 12 is 7. 7, where are we? 7 times 5. 35 modulo 12. What is it? 24. 35 minus 24.
Make 11.
You get 11. Is that not it? You get 11. Thank you. So let's be watching whether we are finished. How much you obtain it? 1, 5, 7, 11. How much you finish? Can you see? Or if you do the 11, let's do the 11. You will see that you will repeat it. Can you see? We have finished obtaining the set, the group. So we could have stopped. So 11H. Let's do 11H. 11 times 1 is 11. 11 times 5, 55. Modulo 12, 7. Can you see? Do that. Have you seen this repeating? Can you all see?
Yes, sir.
So let's see our cosets. So what are our cosets? Let's write it out. What are the cosets? 1, 8. And what? 1, 8. 7, 8. So thank you. So 7, 8. How many cosets do we have? 2. And the number of cosets is equal to the number of elements of the order of the group divided by what? The order of the subgroup. So 4 divided by 2 is 2. So that's why we are getting what? 2 cosets. Are you all here? Yes. 2 cosets. So what's the index? Our index is what? Is 2. The number of the order of H over the order of the order of G dividing the order of H. So 4 over 2 is 2. Any question? Any question? Before you start, you can just use the index to find out how many cosets you'll get. So 4 divided by 2 is 2. So automatically you must get 2 cosets. Are you okay? So you must get 2 cosets.
Why is 9 not part of the group?
9. 9 is not part of the 9 is not part of the elements of U12 because 9 has other factors which is common to this. U means the only common factor should be 1 between you and that thing. You understand? The only common factor between the number and that U should be only 1. If you pick 9, 9 divided by 3 is 3. 4 divided by 3 is 4. So you see, there are other factors apart from 1, which is common to the 2. So it doesn't become part of U. Do you understand the meaning of U now? The unit group. So that's why 9 is not part of U12. Because there are other factors of 9 that is common to the factors of 12 as well. So it makes it not to be an element of U12. So that's the reason. Any other question?
So the left side multiplication. If you multiply by the right side, that's the right side coset. The right coset is the same thing. Like this one, like this is the left coset.
Yes.
If you use the right coset, you're going to get the same.
You get the same, yes.
Yes. So is there any instance where the left coset and then the right coset will be different?
Yeah, infinite. So all the finite are all equal. Every finite group has equal right and left coset. It's only infinite cases that will have the other way around. Either. So every finite group, the left coset is always equal to the right coset.
The 5 and the 11, why are they not part of it?
5 and 11. 5.
No, even 7 and 7 and 11.
7 and 11. Are you watching? He's asking a question. Let's see. He said,
When you are listening to the process,
oh, we are listing the coset.
you list only one.
We listed 1H and 7H. 1H. So this is what we listed. Is that not it?
Yes.
And what? 7H.
7.
Is that not what we listed? Yes. And he said, what is the question?
Why the 5 and
Why didn't we list this one?
Yes.
Yeah, because they are not distinct. They are repeated. This one is the same as this. Can you see? This one.
Can you choose to write the 5?
Yes, you can choose to write this and not this one. Distinct. Are you there? So once we write this one, we can't write this one again because it's repeated. If you write this one, don't write this again because they are equal.
I'm clear.
You are clear now. Very good.
So I was writing when you were explaining why the 9 is not part of it.
Yeah, right. You didn't listen. Well, he was writing. So he didn't hear that. Let's do it here. So he's asking a question. Why the number 9 is not in U12? 9. Okay, it's the same thing. So why 9 is not in U12? Now we are saying that. Let's find the factors of. Let's find the factors. The factors of 12. What are the factors of 12? 1, 2, 3, 4, 6, 12. Now let's find the factors of 9. Factors of 9 are what? 1, 3, 9. Can you all see? So anytime you find the factors of those two numbers, and you cannot have only one that runs through the two of them. If it is only one that runs through the two of them, then that number becomes what? An element of the U. Now, if there are other factors other than only one that runs through the two of them, it means this one cannot be an element of U12. Do you see? There are other common factors between this and that, other than one. So that makes 9 not to qualify to be an element of U12. You're also asking 3. The same thing. So repeat the factors of 3. Factors of 3 are what? 1, 3. Can you see? See, 3 is here. 3 is here. Now look at factors. Let's see why 5 is in U12. Let's see why U5 is in U12. So factors of 5. What? Factors of 5. What are the factors of 5? 1 and 5. What is common here and here? Is it only 1? Only 1. That's why.
So immediately the only common factor between this number and the u is only 1. That means this one is part of it. Do you see? Look at 7. 7. Factors of 7. What are the factors of 7? 1, 7. Is that not it? How many numbers are here that are common to this? It's only 1. That's the meaning. Do you understand why? So that is why 7 is in the group U12, 5 is in the group U12, 3 is not, and 9 is not also in the group U12. Any other question? Any other question? Are you finished writing? Alright. Right.
Again, 38. 111. So we're trying this one. Find all the right cosets of this group. Or what would do? Somebody come to the board and work it. So let's the cosets of S3. Find all the cosets. So you can indicate right coset. The other one left coset is the same thing. We're going to find all the cosets of S3. Hey, sorry. Cameraman. Find all the cosets of H equal to 1 in S3. In S3. Find all the cosets of H1, then 1, 2 in S3. Now, pens are everybody. I want us to do it in 2 ways. We are going to do it in 2 ways. You'll be moving up and down. So let's look at S3. We are going to compute. You know, S3, the digits are 1, 2, 3. Now, we are going to form all the permutations of S3 and we'll write out their cycles. You see that they use cycle. So, I don't want to jump and write the cycles for S3. So, we are going to see how they are generated. Are you all here? So, let's see the permutations of S3. With the digits 1, 2, 3. S3 means 1, 2, 3. Is that not it? Yes. So 1, 2, 3. We know permutations. How many ways you are able to arrange these numbers under permutation? Do you understand? Permutation. You are permitting things. You are rearranging things. So we are going to rearrange this 1, 2, 3 under themselves and see how many times can we do that. I don't know. So let's assume that 1, 2, 3, you are doing the same thing 1, 2, 3 again. For instance, 1 is to 1, 2 is to 2, 3 is to 3. And this is how we call the identity. That's the meaning of this one. It means this is the representation of this. So this is the cycle representation of this permutation. Are you all here? Yes. Now let's see another way we can rearrange 1, 2, 3. So we have put 1 here and put 2, put 3. So let's put 1 here again and send this and bring this. Can you all see? Are you watching? So what do we put here? 3, 2. Can you see? Now watch how to write the cycle. 1 is to 1, so ignore. 2 is to 3. Are you watching? 2 is to 3. 3 is to 2. 2 is to 3. 3 is to 2. 2 is close. Now, you have another, you have to permit again. You have to rearrange. So let's see. We
have 1, 2, 3, and we have 1, 3, 2. Can we maintain 1 again? No. So now let's do swapping again. So now bring 2 here. Can you see? 1, 3. 2, 1, 3. Fine. So we have maintained 3. So 3 is close. Can you see? 3 is to 3. So let's see. 1 is to 2. So the cycle notation of this permutation. 1 is to 2. 1 is to 2. 2 is to 1. Can you see? So you close. You have ended. When it's going back to the first, you close it. That's the cycle. If it's not closing, you continue. If it's not going back to the first, you continue. I hope you have not forgotten. Yes. So let's do again. 1, 2, 3. We have 2 again. We can repeat 2 and now change this. Can you see? 3, 1. So nothing is repeated. Can you see? Nothing is repeated. So let's see how the representation of this. 1 is to 2. Can you see? 1 is to 2. Are you watching? Then 2 is to what? 2 is to 3. Are you watching? 2 is to 3. We are now at 3. So come. 3 is to 1. Can you see? It's coming back. When it's coming back, what do you do? Are you watching how to write cycle of permutations? These are the cycles. Cycle representation of what? Permutations. So let's go on. 1, 2, 3. So we can now maintain 3 here. Can you see? 1, 2. So let's see. 1 is to 3. Are you watching? 1 is to 3. 3 is to 2. 3 is to 2. Are you watching? 2 is to 1. 2 is to 1. So what do we do? Are you all following? How to write this cyclic notation of permutations. So let's go on. So we have this. For this, is that all?
One more.
One more. Thank you. 1, 2, 3. 3 here. 2, 1. So who can give us the cycle of this?
1, 3.
1,
3.
1,
3.
3.
That's what.
So can we see? Very good. So 1 is to 3, 3 is to 1. It's going back. So we close it. This one is repeated. Ignore it. Are you okay? In some books, when it's repeated, they just repeat it. In some books, you see something like this, but it's not necessary. So always believe this. So S3, some books they can write S3 and write all these 6 permutations. Are you all here? They can write S3 in the form of permutations. Then they can also write S3 in the form of what? Cycles. Are you all here? Yes. So they can write all these as elements of S3. They can also write all these cycles as elements of S3. So let's write, because this one is a cycle form, so let's write them. So the elements of S3 are what? 1, 2, 3, 1, 2,
1, 3.
1, 2, 3,
1, 3, 2.
1, 3, 2,
1, 3.
1, 3. Very good. Then close it. Then close it. Then close it. We find the number of elements of the symmetric group is n factorial. When you see n factorial. How many elements has 3? S3 is 3. 1, 2, 3. The numbers are 1, 2, 3. S3 is 1, 2, 3. So 3 times 2 times 1 is what? So that's how we are getting 1, 2, 3, 4, 5, 6.
So the permutation.
The permutation.
Okay, I have an idea that at the end, the S3 should be equal to 6. So when you are permitting it, is it compulsory that they should follow the same procedure, or you can
like
just
this? No, it doesn't mean this one.
you can just do it anyhow. At the end, you should get 6 of them.
Yes.
Like making this one, the last one, it comes somewhere.
This
in
one
the
coming
second-
here.
Yes.
This one, it doesn't matter. That's what that one doesn't matter. You will get the same answer. You can do this one third, you can do this one fifth, anyhow you do. But however you are doing, your target is you are firming they are down. What you are placing under them. That's what we have done. Everything. Permutation, you are firming them. So you are mixing them, you are rearranging them. That's the meaning of firming. Is that not it? So two stake lotto here. Is there any lotto stake here? So they know how to firm numbers. So that's the meaning. So we pen and rearranging them. That's what we call that. Now when we get this one, so now this is our S3. You remember, this is a group and this is H. So how do we do to get the cosets? We multiply each of the elements here by H. Is that not what we have been doing? Yes. Can you all see? Yes. So we multiply each of the elements here by H. And we come out with our process. Do you remember? Yes. So that's what we are coming to do now. In multiplying also, you can choose to multiply the cycles. You can also choose to use the permutations to do the multiplication. Are you all here? So let's do them and then you see what we are talking about. So let's see. We are going to multiply this by this. So let's see what we are going to multiply first. So multiply this by itself. Oh, you get the same thing also. So let's see. So this one, that is this one. So watch. Multiply one by one, you get one. You have one by 8. Still get 8. Can you see? Hey, we still get. What am I doing? 1 by 8. Very good. So let's list it. 1 by 8. You get the same thing, right? So if you multiply this by this, you get 1. Also, yes. If you multiply this by this, you get what?
1,
2. What did you get? Okay. Let's use the permutations,
No, sir, please.
I
didn't get it.
You didn't get?
Multiplying the cycle by the cycles.
Yes. I'm trying to explain that. First, let's use permutations. Let's multiply 1. So let's start. We are going to start. You have to multiply each of this. Is that not it? Yes. By this. So let's do the multiplication. Let's use the permutations. So this one is this. Is that not it? Yes. So the permutation for this is what? 1, 2, 3. 1, 2, 3. They say we should multiply this by itself. Can you see? Let's see why it is the same thing. 1, 2, 3. 1, 2, 3. So let's watch. Let's watch the computation we are going to get here. 1, 2, 3. Please watch. Don't write. So let's see how we do the multiplication. We start from the right. Are you all watching? We start from the right move. 1. We look for 1 is to 1. Come and look for this one. 1 is to 1. Come and look for this one here. Are you watching? 1 is to 1. Come and look for it here. It's what? It's 1 is to 1. Can you all see? 2 is to 2. So we ended at 1. Can you see? 1 is to 1. 1 is to 1. So we ended at 1. Are you watching? 2 is to 2. So look for 2 here. 2 is to where? Back to 2. Can you see? 2 is coming back to itself. Can you see? Now let's go to 3. 3 is to 3. Let's look for 3. Here. 3 is to 3. 3 comes back to 3. Do you see? So you see why when you multiply the identity by itself, you get the same identity. So this one, the cycle notation of this is what? 1. Let's go on.
We are multiplying this. We are multiplying this by this. Let's multiply it by this also. Are you watching? Can you see? So where is 1, 2? What is the permutation for 1, 2 here? Here. Can you see the permutation for 1, 2 here? Yes. Permutation, this 1, 2. Permutation for we are now multiplying 1 by this. So 1 is the same as this. It's coming to multiply by
2, 1, 3.
1, 2 is what? 2, 1, 3. 2, 1, 3. So let's see what we'll get. Let's work together, please. So let's work together. We are starting here. Are you watching? 1 is to 2. 1 is to 2. 1 in the white. Tap in. Where did you go yesterday? So let's go. Are you watching? So 1 is to 2. Can you see? So where my hand is there, let me come and look for it here. Can you see? 1 is to 2. So look for 2. And then 1 is to 2. So look for 2 here. 2 is to where? 2 is to 2. So here will be 2. Are you watching? Someone said,
Yes.
You see? Now let's go. 2 is to 1. Are you watching? 2 is to 1. So let's go for 1. 1 is to where? 1. So it comes to here. So, can you see? 3 is to 3. 3. That's how we multiply permutation. So now, what's the cycle for this? 1 is to 2. 2 is to 1. Can you see? 1 is to 2. 2 is to 1. Close. Can you see?
How is this a multiplication?
Huh?
How is that a multiplication?
How confused because we multiply this by that.
This one.
That's how multiply permutation is. Yeah, so you get an answer. So we are writing we are coming to write all the product. You remember that one? We're multiplying all the elements of H by all the elements of G by the elements of H. Is that not what we did? Yes. So you pick this, multiply by this. Pick it again, multiply by this. Can you see? So when we multiply this by this, this by that, we had this and we had that. Can you see? So one of the cosets is what? So how do you write this? What we have just done? How do you write it?
The coset.
1, comma.
1, 1, 2.
Who can tell us?
8.
So it's 8. This one, what did we do?
So the most set of
3 is to 3. Can you see? So let's look for 3 on the left side. 3 is to where? Cameraman, are you starting? Can I go? Okay. So let's write out this. What did we do here? We multiply 1 by 8. Is that not it? Yes. This 2. Can you see? So 1 by 8. What did we get? What did we get? We got 1. Can you see? Then here, 1, 2. Can you see? What you finish doing, write it out. One of them. Can you see? Like we were doing. So take note. So now let's go. We are not coming here. We now want to multiply 2, 3, and we are multiplying 2, 3. Yes. By 8. Can you see? So let's multiply it. Let's use the permutations. So we are multiplying 2, 3. So let's multiply 2, 3. Can you see? We want 2, 3 by identity. 2, 3 by the other one. So after that, we'll write it here. So let's do 2, 3. What is the permutation for 2, 3?
1, 1.
Permutation for 2, 3 is what? 1,
2. 1, 3, 2.
1, 3, 2. So multiply by this one first. Can you see?
Are you see? So let's multiply. 1, 2, 3. 1 is to 1. 1 is to 1. 1. Are you watching? Stop writing. 3 is to 2. 3 is to 3. 3 here. Are you see? 3 is to 3. 3 is to 2. Are you see? 2. So you can write a cycle for us here. 1 is to 1 is 1. So 2 is to 3. 3 is to 2. Close. Can you see? Who's confused? How is that confused?
I'm not confused.
I see.
I think that you are getting the
Oh, we're supposed to get the same thing. We're supposed to get the same. We're supposed to get it. Like we're doing. So don't be confused. It's the same thing. So the group, everything you are getting must be inside the group because partition from it. Easy. So I finished multiplying this by the identity. So now let's multiply it again. The same thing again by multiply it again by 1, 2. Can you see? And what is 1, 2? 1, 2 is here. Can you see? We're using the permutation for 1, 2. Permutation for 1, 2. Read it for me. It's what? 2 and 3. Thank you. Permutation for 1, 3. For 1, 2 is 2 and 3. This one. So now we're going to multiply this by that. Okay. 1, 2, let's go. So let's write the cycle for this. Who can tell us? Charlotte. The cycle for this we were 1, 3. 2. 1 is to 3, and 3 is to 2. I see. 2. Very good. Thank you. Then 2 is to 1, you see. So it's good. Very good. Any questions? So we have done multiplying by this and this by that. So that is this one. What is this? This one, 2, 3 by 8. So let's write out the answers we have. Now you all see. So multiply this one by this. I will have these two answers. So let's write them out. We have this 2, 3. We also add 1, 3, 2. Don't be confused, it's the same way we are doing, the same approach. So let's go to the next. So pick this one and multiply again. Do you see? We're not going to pick the third element of S3, just like we're doing G. That's G. This set is G. This group is G. Pick the next one, multiply by H, like we did previously. So 1, 2. What's the permutation for 1, 2? Who can read it for us? What is 1, 2? Right here. 1, 2 is what? 2, 1, 3. So multiply it by the first one. 1, 2, 3, 1, 2, 3. So let's multiply and see. So multiply it by 1, 2, 3. So 1 is to 1. 1 is to 2. So here is what? 2. 3 is to 2, and then 3 is to 1. So here is what? 1. Are you watching? 3 is to 3. 3 is to 3. So what is here? 3. There will be no number that will be repeated down there. It's not possible. Can you see? So somebody should write a cycle correct. 1, 2. 1 is to 2, 2 is to 1. Can you see? So it's close. Can you see? 1 is 2, 2 is to 1. It's close. 3 is to 3. When you use the permutation to do the multiplication, it's very easy to get it. Do you see? After that, we will still use the cycles to do the multiplication. I want us to get it. This one is very cheap to understand. You see, this one is very easy to understand. When you are using permutation to multiply, when you are using the cycle to multiply, it's a little distance. But this one is very easy to do the multiplication using the permutations. So we have multiplied this by identity. So now let's multiply it by the next one. The same thing. Can you see? So we are multiplying 1, 2, 3. We are multiplying 1, 2 by 1, 2. So what is 1, 2 here? 2, 1, 3. The 1, 2, 3. We have multiplied 1, 2, 3 by this. The 1, 2, 3. What is the percentage for 1, 2, 3? Look at that.
3, 1.
2,
3, 1.
3, 1. Okay. So multiply it by this, the unit. Identity. Let's multiply by the identity and see what do we get. 1 is to 1. Can you see? Yes. Stop writing. 1 is to 1. 1 is to 1. 2. Can you see it? 2 is to 2. 2 is to 1. Right. 3 is here. 3 is to 3. 3 is to 1. 1. So what do you get? 1, 2. 1 is to 2. 2 is to 3. 3 is to 1. Can you see? It goes back. So close. Have you seen? Huh? Yes. We are multiplying this by h. So we are multiplying it by this. We are multiplying it by this now. That is 1. Multiply it by 1, 2. So what is the permutation for 1, 2? You can tell us.
2, 1, 3.
2, 1, 3. So let's see. So let's multiply. 1 is to 2. 2 is what? 3. So 1, 3. 2 is to 1. 1 is to 2. 2. 3 is to 3. Are you watching? 3 is to 3, 3 is to 1. 1. Is that what it is? So we can give us the cycle for this. 1 is to 3. So 3 is to 1. Very good. That's all. Can you see? So we have multiplied. What did we multiply? We multiplied 1, 2, 3 by h. Is that what we did? Yes. These two. So these two, we multiply 1, 2, 3 by h. So let's write out the result. What did we get for them?
1, 2, 3.
1, 2, 3, and what?
1, 3.
1, 3. So let's see whether, has it repeated?
Yes.
Has it repeated? Please. 1, 2, 3 by h. We had 1, 2, 3, 1, 3. What is the other one? We had 1 by 8. We had 1 and 1, 2. What is the other one? 2, 3 by 8. We had 2, 3, 1, 3, 2. 2, 3, 1, 3, 2. Then here, okay, 1 and 1, 2. This one was repeated. So we are finished. Can you see? Are we gotten all? No. Let's count. This is 1 by 8. 1h. Can you see? The identity by 8 is the coset. Now what is the next coset? This one by this. We had this. Are you watching? So this one. This one. So this one 1. 1. 1, 2. 1, 2. Then here 2, 3.